Somewhere in Rome right now, there's a dome that's held itself up without a single crack of structural failure for almost 2,000 years. No rebar, no steel reinforcement, just concrete, poured by people who didn't have modern chemistry, modern machinery, or a single calculator. Meanwhile, the average modern concrete structure in the United States is expected to last somewhere between 50 and 100 years. Highway overpasses, parking garages, sidewalks that crack within a decade of being poured. The American Society of Civil Engineers has repeatedly given the country's infrastructure a grade somewhere in the C to D range, and a huge part of that comes down to one material: concrete that simply doesn't last the way we need it to. We built the tools to send people to space, and we still can't make concrete as durable as the Romans did with volcanic ash and seawater. For centuries, nobody could explain why. The recipe wasn't lost because anyone hid it. It was lost the way most ancient knowledge disappears, quietly, generation after generation, until nobody left alive remembered exactly how it was done. Here's what we did know. Roman concrete structures, like the Pantheon's dome, still the largest unreinforced concrete dome on Earth, and Roman harbor walls that have spent 2,000 years getting hit by ocean waves were still standing when equivalent modern concrete structures would have crumbled decades ago. Some Roman piers, sitting directly in seawater, constantly battered by waves and salt, a combination that destroys modern marine concrete in a matter of years, have survived for 2 millennia, and in some cases, actually gotten stronger over time. Scientists had one major clue sitting right in front of them the entire time, and for decades, they got it completely wrong. If you look closely at ancient Roman concrete, you'll find small white chunks scattered through it, called lime clasts. For most of the 20th century, engineers assumed these were a mistake, evidence of sloppy mixing, a sign the Romans weren't as careful as everyone assumed. It became one of those quiet, unquestioned facts passed down through generations of architectural historians. The kind of assumption nobody thinks to challenge, because it's been repeated so many times it starts to sound like established truth. In 2023, a materials scientist named Admir Masic, working with a team at MIT, decided that explanation never quite made sense.
Here's his reasoning. The Romans were remarkably precise engineers. They built aqueducts with almost imperceptible downward slopes across dozens of miles, maintaining a grade so subtle it's difficult to replicate even with modern surveying equipment. They calculated dome geometry that wouldn't be matched again for over 1,000 years. Masic's question was simple. If the Romans cared this much about precision everywhere else, why would they suddenly get sloppy with the one material holding their entire civilization together? So his team took a closer look at those lime clasts under a microscope. What they found rewrote the story completely. The clasts weren't mistakes. They were evidence of a specific technique called hot mixing. Instead of slaking lime in water first, the way historical texts assumed, the Romans appear to have mixed dry quicklime directly with volcanic ash, then added water while the mixture was still extremely hot. That intense heat did something remarkable. It left behind small, reactive pockets of unreacted lime, locked inside the concrete in a brittle, nanoparticle structure. And that heat had a second benefit the researchers hadn't initially expected. It dramatically sped up the curing process, allowing the Romans to build faster while simultaneously creating a more durable final product. An efficiency gain that modern construction, focused entirely on speed and cost, has almost completely overlooked. Here's why the lime clasts mattered.
When cracks eventually form in the concrete, and cracks form in almost every concrete structure over time, those cracks would sometimes reach one of these lime pockets. Water would seep in, and the lime clast would dissolve, creating a calcium-rich solution that flows into the crack and recrystallizes, sealing it shut. The concrete was quite literally healing its own wounds, automatically, without a single person ever repairing it. No maintenance crew, no inspection schedule, just a material that had been engineered, whether intentionally or through centuries of accumulated trial and error, to repair the exact kind of damage it was most likely to sustain over its lifetime. Modern concrete doesn't do this. Portland cement, the material behind nearly every sidewalk, parking structure, and building foundation in the country, forms cracks that just stay cracks, slowly letting in water, salt, and rust until the whole structure eventually fails. Every pothole you've ever driven over, every crumbling parking garage, every bridge inspection that turns up hairline fractures is a small reminder that we traded durability for speed and lost something along the way that we didn't even realize was missing. There's one more twist to this story, and it's the part that should genuinely bother you. The most complete surviving architectural text from the Roman world was written by a Roman engineer named Vitruvius. His work has been studied by scholars and architects for centuries, treated as close to a definitive record of how the Romans actually built things. If any document should have preserved this secret, it should have been this one. Vitruvius describes slaking lime in water before mixing it with other materials. He never mentions hot mixing at all, which means the single most trusted written record we have from that era doesn't even contain the real secret. The actual technique either wasn't considered worth writing down, or it was common enough at the time that nobody thought a future civilization would need it explained. It's the same pattern this channel keeps running into, over and over. Knowledge doesn't just disappear when books burn or languages die. Sometimes it disappears because nobody thought to write down the thing that seemed too obvious to ever forget. Either way, the knowledge didn't survive in the texts. It survived, silently, embedded in the concrete itself, waiting nearly 2,000 years for someone to finally ask the right question.
And this story isn't finished. In December 2025, the same MIT team examined a newly excavated construction site in Pompeii, frozen in time since the eruption that buried it in 79 AD. They found intact quicklime fragments mixed dry with volcanic ash in a raw material pile, exactly the ingredients hot mixing would require, caught mid-process before a single drop of water had even been added. It's about as close as you can get to catching a 2,000-year-old construction crew in the act. A civilization that vanished, caught with its hands still on the tools. So why does any of this actually matter to you, watching this today, in a country full of crumbling infrastructure? Because engineers are already using this discovery. Researchers have started testing modern concrete formulas that deliberately include lime clasts, designed the same way the Romans accidentally or intentionally built them in. Early results suggest these self-healing mixtures could dramatically extend the lifespan of everything from seawalls to bridges, cutting down on the constant, expensive cycle of crumbling and rebuilding that defines so much of modern construction. Some of that research is even aimed specifically at reducing the carbon footprint of concrete production, since a material that lasts 5 times longer needs to be poured and manufactured far less often.
The ancient Romans didn't leave behind a written formula. They left behind something better and stranger, the evidence baked directly into the material itself, durable enough to outlast the empire that built it, the language it was recorded in, and every generation of engineers who came after, until one team finally knew what question to ask. Somewhere in Rome, that dome is still standing. Somewhere in Pompeii, an unfinished pile of concrete ingredients just told us something no book ever did. And somewhere near you, right now, there's probably a crumbling sidewalk that could have lasted 2,000 years if only the right question had been asked a little sooner. Thank you for watching all the way to the end. If this made you think differently about something you thought you already understood, that's exactly what this channel is for. Subscribe to Vanished Knowledge, and I'll see you in the next one.